Hello. Let's take a look at solving a couple of questions involving mass energy equivalence. Now, this first question here says the nuclear binding energy of an isotope is 448 mega electron volts, and they're asking us to find the nuclear mass defect. Now, it's important to know that mass defect is really just saying what's the mass that's equivalent to this amount of energy. So we see that it's 448 mega electron volts, and we know that electron volts are an energy unit. We can convert this into mass by first going through joules and then using Einstein's equation E equals mc squared to convert those joules into kilograms and then convert the kilograms into atomic mass units. So let's start with the 448 mega electron volts, and mega is 10 to the 6. So this would be 10 to the 6 electron volts. And we can convert this into joules by using our ratio, and the electron volts will cancel out. And then this works out to 7.168 times 10 to the negative 11 joules. So keep the calculator answer in there. Now we can see that this is energy in joules, and we can use Einstein's equation there, as I mentioned, and solve for mass. So let's put that value we just calculated and divide it by speed of light squared, all squared. And this now works out to 7.964 times 10 to the negative 28, that's a 10, kilograms. So we have the value for mass in kilograms, but we want to change it into atomic mass units. So let's take this mass of 7.964 times 10 to the negative 28 kilograms, and we'll convert that to atomic mass units by using the value on our data sheet, the equivalent value that is in kilograms. So it's 10 to the negative 27. And then this works out to 0.480 atomic mass units. So there we have a conversion of energy in electron volts through joules, change the joules into kilograms using E equals mc squared, and then change the mass in kilograms to atomic mass units. And we need to understand that this mass in atomic mass units is equivalent to the energy. Now we have a couple other questions here. Let's go to number 9. This is out of our Edmonton Public Schools workbook, the coiled workbook. Here it says, by experiment, using a mass spectrometer, the mass of hydrogen-2 has been determined to be 2.014 atomic mass units. So they're giving us a specific atomic mass unit. But the individual masses of the particles that make up the hydrogen-2 atom were mathematically summed to be 2.016 atomic mass units and determine the binding energy. So first of all, we're dealing with more specific amounts in atomic mass units, and we can also see that the individual sum of the protons and neutrons is greater in mass than the whole nucleus of hydrogen-2. And also, when we're asked to determine the binding energy, that just means what is the energy equivalence to this mass defect. Now, first of all, mass defect is the difference in the mass of the sum of the nucleons and the entire nucleus. So let's take the 2.016491 atomic mass units and find the difference between that and the nucleus, the entire nucleus. So this is the mass defect in atomic mass units. Then we can change that mass defect to kilograms. Now again, this is that kilogram equivalent to the atomic mass unit on our data sheet. So we get 3.9657 times 10 to the negative 30 kilograms. Now, if we know the mass in kilograms, we can find the energy using our Einstein equation. So let's write this mass and multiply it by the speed of light squared. And that energy is 3.5691 times 10 to the negative 13 joules. So we have our energy in joules, and then we just simply need to switch that into electron volts to find this nuclear binding energy, or the energy equivalent to the mass defect. So let's take this value in joules, and we'll change it to 1 atomic mass unit is 1.60 times 10 to the negative 19 joules. So joules cancel, and we get 2.23 times 10 to the 6 electron volts. Well, that just means mega electron volts. So 2.23 mega electron volts. And that's our equivalent energy. One last question. Here we have something a little bit different. They give us actually the individual nucleons, and we still want to find the binding energy. So this is just like the question we just did, except that we have to add the individual nucleons first. So let's take the 2 protons that are in the helium nucleus and multiply that by the value that's given in the question. This is a 0. And we'll add that to the 2 neutrons, multiplied the value that's given in the question. Okay, so this becomes 4.032 atomic mass units. Now we can do the mass defect, and the question ends up being the same as what we just completed with question number 9. So we'll subtract the mass of the nucleus from the sum of the nucleons, and this mass defect is 0.0294 atomic mass units. Then let's change the atomic mass units to kilograms. By using our conversion, and we get 4.88 let's go 0.4 times 10 to the negative 29 kilograms. Once we have our mass in kilograms, let's change it to joules. In other words, calculate joules. By multiplying by the speed of light, all squared. So this energy is 4.39236 times 10 to the negative 12 joules. So now we have our energy in joules, and we convert it to electron volts. And we know that I'll put the right value in there. So there's our value in joules, and we know that 1 electron volt is 1.60 times 10 to the negative 19 joules. Joules cancel, and we get 6.86 times 10 to the 6 electron volts, or 6.86 mega electron volts. And there's our energy equivalence. Thanks so much. Pause the video when you need to go over things. Goodbye.